Is now streaming on Facebook.
And we are live. Welcome to another Maryland STEM Festival event. We are very fortunate today to have Will G from BaltiVirt. They have created many amazing augmented and virtual reality experiences for a wide range of companies, but I can't describe it as well or certainly display it as well as Will can. So I'm going to turn it over to Will so he can explain to you and talk to you about virtual reality and augmented reality.
Awesome. Thanks so much for having me. And again, a lot of what we build is very interactive. And so I'd love for this presentation to be as interactive as possible.
Oh,
So if
let me
there are
just
questions, please shoot
just
them into the
real
chat.
quick. I'm sorry, Will. If you'd like to post anything on social media during the event, encourage people to join or watch us on Facebook. Our hashtag is MDSTEMFest. And as Will mentioned, feel free to post questions in the chat box and I will relay them to Will. So Will, take it away, and we're looking forward to a great program.
Awesome. So really quickly, Will G, co-founder, CEO of BaltiVirt. We're a software studio here in Baltimore that builds augmented and virtual reality experiences for a lot of different brands and organizations. Work with groups like HBO, Under Armour, Starbucks, a lot of sports teams, all kinds of different people. And we're going to spend a little bit of time this afternoon talking about virtual reality and augmented reality. Kind of start by defining what those things are, and then dive into some of the work that we're doing. All right, so let's see, I'll switch us over to the slides here. Cool. So quickly, I'll give a quick introduction to some of our work. It's very visual. Talking about it doesn't do it justice. It's really much better to see it in action. And then step back into a little bit of the history of virtual reality, augmented reality, where these things came from, where they're going, and then do some demos and kind of show off some of the things that we're doing these days and show off some of the newer pieces of tech, including the Microsoft HoloLens too. So I love this quote. I think it sums up VR, AR, technology in general, STEM. This stuff has sort of a magical quality to it. Once you sort of look a little bit beneath the surface, you realize it's just a lot of engineering, it's a lot of hard work, and a lot of careful creation that goes into this magic. Here's a quick demo reel of some of our work. Starting with Marvel, we did some augmented reality work with a lot of their characters. You can see Captain America and Groot and Iron Man. This is some web-based augmented reality we built for a few different brands. This is a virtual reality and immersive training project we built with the Army to kind of teach some different soldiers how to assemble equipment. Obviously, our work runs a pretty wide gamut from things that more resemble a video game to things that are more training or education. There's a project we did with Under Armour, Jordan Spieth, and Cam Newton. So again, our work kind of goes in a lot of different directions, but it spans ultimately this space of virtual reality and augmented reality. So I'm going to take a minute and kind of describe those terms. So what is virtual reality? Well, the easiest way I know to describe VR is to say VR uses a headset to take you anywhere. And that can take a number of different forms. That can be these old school looking headsets from the 1990s to more modern, smaller headsets like the Oculus Quest, and really anywhere in between. Oops, got a double here. There's actually the first VR headset on the left there. We're going to touch on that a little bit later. So quickly, virtual reality comes in two main flavors. If you're familiar with VR, you've probably seen either 360 video, and this is kind of where VR really became pretty popular in the last few years. This pictured is one of the early incarnations of a 360 camera. It's literally people would 3D print these rigs to attach 16 or or 20 GoPros in a ring, sync them all up, record, and then pull all the data out on the back end, run it through a bunch of computer, processing algorithms and things like that, and stitch it together into something that you
Sorry, I didn't catch that.
examine in 360. These days, that whole ring of GoPros has been replaced with something small, portable, handheld like this consumer VR 360 camera. So we've come a long way even in the last 5 or so years. So the other flavor of, and this gives you kind of an example of what that looks like. You can kind of pan around these videos. This is the output of one of those 360 cameras. The other type of VR, aside from 360 video, is real-time or interactive. And this is what BaltiVirt specializes in. We spend most of our time building things that kind of look and feel like a video game. And it gives the user the ability to change what they're seeing rather than just sort of being more of an observer. So here's a quick example of that. Very popular VR game, Beat Saber. The user has 2 lightsabers chopping blocks. So a really simple game that's super fun because you're immersed in it and it's kind of using your full range of motion. So that's virtual reality. It's putting on a headset, feeling like you're in another place, either coming from video or something like a video game. But then augmented reality is kind of the other side of the coin. And the way that we define augmented reality is AR adds computer graphics to the real world. And this can come in a lot of different forms. And people have seen these types of experiences. On the right is arguably the most popular incarnation of augmented reality in all times. That's the first down line in football. So if you've watched a football game, you've seen this imaginary line that's not there. That's a really simple example of AR. Kind of a little bit of trivia on the first down line that was first used in a Baltimore Ravens game in 1996. So again, a little Baltimore augmented reality roots. And on the left, you've got someone who's going crazy with Pokemon Go, playing 8 games or whatever at the same time. Both are different versions of the same thing. Augmented reality kind of combining a sense of computer graphics with a view of the real world. And finally, another fairly popular example of AR are these snap filters, Snapchat, Instagram, these kind of types of AR where you're overlaying computer graphics on a view of yourself. So all sort of different sides of the same thing. One big difference between augmented reality and virtual reality is that AR is mostly experienced through smartphones, where VR requires specialized headsets that not a lot of people have yet. AR is something that much more accessible because billions of people have smartphones today. And so that's a huge opportunity. That said, a lot of people think that the real next big leap in this is when AR moves into headsets, like a light pair of glasses. I've actually got an AR headset to demonstrate in a little bit that is not quite this light, but it gives you some sense of what the ultimate experience will look like there. And finally, XR. I don't know if anyone came in early, but when I was waiting, I kind of have this, please stand by for XR. XR is a term that sort of started to emerge really about 4 or 5 years ago. And at first it was kind of like, oh boy, we've added a new term to our repertoire just to confuse people even more, AR, VR, whatever. But I think there's something really helpful here where this idea of XR, extended reality, some people say MR, mixed reality, but kind of things that don't cleanly fit into AR or VR. And there's some kind of amalgam of the two. I think this is a really helpful way. I found this illustration online of thinking about what XR is. So you've got kind of how much real life you're seeing, right? So if we were together in a room doing this presentation, we would be seeing each other in actual reality, right? We wouldn't have any computer graphics folded into the mix. And if we all had VR headsets, we'd be over here on the right side, completely in virtual reality. But then if you're wearing a headset that has the ability to kind of mix these two things together, that's kind of this spectrum of XR, mixed reality, and so it's not necessarily a clean, I'm in AR, I'm in VR. So I think that's where XR is kind of a helpful way of thinking about these terms. So I guess I'll pause there. Was there a question or? Oh, Andrew. Yeah, absolutely. Cool. I'm definitely going to dive into some of the stuff that we build and how we build things. We do use Unity. That's how we develop both augmented reality and virtual reality. Before we started using Unity, we actually wrote our own game engine. We developed a VR tool in about 2006 for the NFL, and we wrote our own engine for that. But ultimately, the value that we get from using Unity is pretty amazing, especially for the cost and all the features you get and the giant team that's behind it supporting it. So cool. All right, so let's go. I'll quickly run through kind of a history of where this stuff came to be and how we got to the place that we are right now. So the first VR device, arguably, was in the early 1800s. Is the home stereoscope. This is basically a set of lenses that display two images side by side, kind of doing roughly the same things that a modern VR headset does, where it uses lenses to make the images appear larger and more immersive, kind of wrapping it around your field of view more, presenting different images to your left and right eyes, and pretty amazing that, again, almost 200 years ago, we started using the same technology. Things didn't advance very much in the ensuing 100 or so years. Moved on to basically this, which is the Viewmaster. I think Hasbro was involved in that as well at some point. Mattel.
I had one of those. Probably I had a couple of those.
Exactly, same kind of idea, right? A couple of lenses, left,
Yep.
right, different images on the left and right to give you to kind of trick your sense of depth. And but really roughly the same thing as the stereoscope from the 1830s. Around that same time, though, there was Ivan Sutherland, who is kind of the father of computer graphics, really one of the early inventors of using a computer to render lines and 3D geometry and points. After he sort of got that initial display on a screen working, the next logical step for him was, how do we put this on someone's head? And they built this immersive display called the Sword of Damocles, or it was kind of nicknamed that because it was a giant contraption that hung from the ceiling over a person's head. So you can picture here these two cathode ray tubes bouncing off of mirrors. And this whole enormous kind of contraption, let's see, I should have a video. Let's see if this can come up. Yeah, this is the Sword of Damocles in action. So you're seeing someone moving around, and ultimately what it rendered was just this very simple cube. So a simple wireframe cube to this enormous contraption created that. So, but yeah, 1965. It's very early. I mean, and things sort of sat that way for a bit. There was, I think, there was something called the Sensorama that I've had in some of these presentations. I don't know if anyone's seen that, but that was kind of a pretty wild device. It was like a coin-operated VR device where you sit in this thing, and you're watching with a giant projection screen, a recreation of a motorcycle ride through New York City. And it included vibrations on the seat. It had a fan to blow wind on you. It even had smell. So you'd go by like a pizza shop and smell pizza. And I think people thought that this was going to be really the future of entertainment, right? Like we've gone from black and white cinema to color, and then it was like, great, let's add all, smell, vibration, stereophonic sounds and all this kind of stuff. Ultimately, it was not very popular. I guess people didn't need smell embedded in their VR experiences. 1990s was a pretty popular time for VR, kind of went through a massive renaissance. I don't know if anyone here remembers the Sony Walkman, but it was the early cassette player. Well, shortly after the Walkman was introduced, Sony had a follow-on product called the Watchman, which was a portable LCD TV screen. And as you might imagine, it had pretty intense battery requirements. And so I actually had one of these devices. It was about this big. It had a color screen about the size of a postage stamp. And it took like 4 AA batteries to run it for about half an hour or something. Like it was pretty insane. But just by virtue of the fact that a company the size of Sony was producing all these LCD screens, and it sort of was like a thing that a lot of electronics manufacturers got into, there's kind of a glut of inexpensive screens. And so people thought, well, we could use them for these VR devices. And so back then, there were there was a big push into VR, and there were films like Lawnmower Man and all these different things where people thought VR is going to happen any moment now. There were some pretty major technical limitations back then. Mainly, the displays were not fast enough. So I don't know if anyone has experience with VR, but one of the biggest things that you have to do in order to keep things comfortable for people is to quickly update the display. So draw at 90 frames per second, ideally more. And these displays can only draw at about 20 to 30 frames per second. And so immediately they sort of made people feel, kind of nauseous. It's that simulator sickness thing. Also, computers back then were not very good at 3D graphics. Like they've gotten, following Moore's law, they've become thousands of times more powerful than they were back in those days. So all of that conspired to make the VR of the 90s not very good. We're currently kind of in this renaissance of VR. Really started with Oculus and then quickly followed by companies like HTC, Valve, Google, all building VR devices. Much like the 90s, this is all kind of coming from another set of devices. Really, and you can kind of see here, the fact that everyone has a smartphone, and we're producing millions and billions of smartphones that all use high performance processors, really nice displays, and a set of sensors, things like gyroscopes and accelerometers for sensing rotation that can all be used to make great VR. And so that's where this current wave of virtual reality has really kind of sprung forth. 2018, Google released this standalone device. It's pretty good. Really much better was the 2019 Oculus Quest. And actually this year, the Oculus Quest 2 is kind of the state of the art in virtual reality right now. There are definitely some issues in terms of integration with Facebook and some kind of clunkiness, but it's definitely the closest thing that I've seen to a mass market VR device. So, I mean, kind of taking a step back, talking about like the history of VR, the history of my life with computers and technology, I've seen a lot of different things come along. I was a kid in the 80s and 90s, and so computers weren't super common in the 80s. Some people had them. They had an Apple II. if they were really kind of interested in technology. But it wasn't the type of thing where everyone was walking around with a computer like they are today with a smartphone. By the same token, in the early 90s, the internet sort of was not very user friendly. You kind of had to figure out a bunch of networking settings, have your modem dial in, and then there was kind of the AOL, these kind of easier to access internet services, and then it just sort of became a thing that people can do super easily. I think VR is somewhere in the early stages of that curve, or if you want to say XR in general, definitely in the early stages of that curve. So devices like the Oculus Quest are really a helpful step in that progression. So kind of looking forward to seeing how that continues to evolve. So yeah, anyway, let's see our work. We can quickly talk through some of these projects, and I know Andrew might be interested in some of the details of technical execution on these, so we can kind of jump into this as needed. And again, anyone feel free to send any questions. I'd love for this to be a conversation, kind of jump in and talk about some of the different things that we've done. So here's our super impressive list of clients. Let's jump into some of the things that we've actually done for those clients. So this is a game that we built for the Washington Capitals, starring Alex Ovechkin. We built this one actually not using Unity, but using Snapchat Lens Studio. It's a great tool. It's for building smaller experiences, things like face filters, or even small games, which is what we did in this case. We built a little hockey game that can be triggered off of this cereal box of Ovios. So you can see when you scan the box, this game kind of comes to life in 3D. It was all animated in 3D Studio Max, and then the materials and things like that were set up within Lens Studio. And all the code and logic were written in JavaScript in Lens Studio. So this was a really, really fun project to work on. Again, kind of just the fun of working with the Washington Capitals and Alex Ovechkin. Here's a game that we helped build as part of the Harlem Globetrotters app. So this was built in Unity using a couple of different pieces of technology. So this is something that we partnered with the developers of their app, and the developers built the kind of traditional aspects where you can see the Globetrotter schedule or buy merchandise or buy tickets or things like that. And then there's this other mode where you can access face filters and an actual augmented basketball game. So here are the face filters. We built these in Unity using some middleware. This stuff can be done now with AR Foundation. And then here's the basketball game. Again, we built this in Unity using, this one was with ARKit and ARCore. A lot of this stuff, I guess I'll pause for a second because some of the tools used to create this. One of the really exciting things about that is when I started in the game industry as a software developer, a lot of the tools that you used to build games, especially the ones that were really nice and kind of designed for professionals, they often cost thousands, if not hundreds of thousands of dollars. At one point early on in Unreal Engine 3's life cycle, it used to cost $1 million to license their engine. If you wanted to build, a AAA game, it was extremely expensive. You had to commit to that up front. And so it really kept a lot of people from being able to experience what these types of products work like firsthand. And so I guess I'm just thrilled to see that these days, Unreal is more or less free. Unity is more or less free. You can go download these engines. They've got great sets of tutorials and help files for getting started. Unity actually just released a really fun collaboration with Lego. So they've got a whole set of presets where you can build Lego games, and people have actually already gone in and imported other packages in with the Lego games to build VR Lego experiences. Again, this is just kind of dragging and dropping a couple of things It's super accessible. There are tons of resources on the internet. It's, again, I'm really, really excited because I think it's just there really hasn't been a better time to try to develop this stuff. There are so many different tools and technologies that you can experiment with. Most, if not all of the major ones are free. So it's an exciting time. So here's a project we built. It's kind of a multi-user collaboration system, and we called it Minerva. And the idea is, it was obviously built pre-COVID, when a lot of people would want to collaborate in a single space, but it's something that adapted fairly well to being remote. And the way that looks is, it's like this. So basically what it was you could take a bunch of users that were either using AR headsets. In this case, we used something called the Magic Leap 1, and also users with iPads. So this first scene that you can see here, one user is looking through an iPad. There are a couple guys over here, Nomi and Sean from our team. They both have on these Magic Leap headsets, and everyone's looking at the same model of a car together. And so it's as if there's a physical hologram in the middle of the room with them, and they can all walk around to it, and they're seeing things from a consistent and shared point of view. So again, it's as if there was a 3D model floating in the room, and if I walked up and pointed at the left or at the driver's side mirror, everyone else would kind of see everything lined up in that same way. So it was a really, really cool tool for us to build, and just we're excited about the potential of it. Yeah, so they're walking around looking at a Tesla, kind of running some simple animations of stripping away some of the major components, showing what's going on there. And again, multiple users collaborating, pointing at things as if there was a real car in the room with them. But obviously, it's a lot easier to bring a hologram into a room than it is to bring a full-size Tesla. So that's something we're excited about longer term, the idea of using these types of tools to collaborate, especially across distance, share information, and really have like a rich interaction with other people. I should skip this one. This one is a tool that we built with the Army, or a prototype with a company called NetC Technologies and the Aberdeen Proving Ground. And it was an Oculus Quest demo. And I guess I'll stop here for a second. What it was used for was, there's a piece of equipment that's an inflatable antenna, and it takes about 20 to 30 steps to assemble this thing. And the traditional way that someone would learn how to do this is to watch either a video, like a training film, go through a PowerPoint, or read a manual. And we thought using this type of technology would be a lot more captivating, a lot more interesting. So what we built was, you put on a VR headset, you go in, you're looking at the case that this piece of equipment comes in, and there's an arrow pointing to it saying, step 1, open the case. And you open the case, and then step 2, take it out and put it down here. And step 3, wire this thing to that thing. And it really just walks you through using overlays to the view exactly how to do this process. And so I'll show you kind of what that looks like. So again, they're saying, okay, instead of the classroom, put on this headset. And step into a simulation. And the cool thing about this is that people could do it on their own time. They could do it wherever they wanted. You don't need particularly a lot of space, but you get that sense, and it was something that we saw with our early project with the NFL, that when people learn by doing things, even if it's a simulation, even if it's a virtual experience, it's just a much more powerful way to learn and remember things. You know, you kind of build that muscle memory, you build that ability of like, okay, I know exactly how that works. I think just, especially for my mind, I'm very much kind of a kinesthetic learner. I like to learn by doing. I like to learn by picking things up and tinkering. You can see I got this workbench over here on my third floor. I'm constantly kind of playing with things and tinkering with them. And so that way of learning is really powerful for me. And I think a lot of people as well. Well, yeah, let me see if we can, I'm going to do a quick demo here of the Microsoft HoloLens. So let's see, just give me 1 second so we can pick this up. And try to get this thing streaming. Okay. Cool. All right, so I'm going to show off. This is first-person view of my workshop, you know, and looking through HoloLens. Here, enter this application called Graffiti 3D. And Phil, are you seeing this? Is this coming through?
I mean, I'm seeing your desk, so I'm seeing. Yeah, I see the keyboard floating, so yeah.
Cool. Okay. Yeah. So I mean, again, like if I've got this model of a bird, right? Say I wanted to illustrate something around that. Put it back together. But yeah. So I can just draw in space. It's actually kind of hard to see that. Put this model back together. It's kind of hard to see with this overlay. Alright. So again, I was going to draw, like, you know, illustrate like here. You know, again, very simple example, but like imagine if I had a searchable index of where are all of the resistors in this workbench. You know, it just kind of came up with arrows where it was like here, here, here. So this kind of melding of physical and virtual is extremely powerful. And again, I can show you all kinds of things. The cool thing about the HoloLens is the start menu is just this little clicking on your wrists type of thing. This is a little sample application that we built in Unity using the Bing Maps toolkit. And again, this is just kind of overlaying some information over Baltimore, specifically major points of interest. Drag around this 3D map. Zoom in. And again, I mean, I think these types of displays would be interesting in 2D on a screen, but I think there's something really powerful with just being able to move around them and kind of understand them from any angle, walk through them, interact with them in the same way that you interact with everything else in your life, right? Like the way that you interact with your fork in the morning, or the way that you literally deal with just about anything. So I think there's something really, really powerful and exciting about using those types of digital models and interfaces. So let's just stop for 1 second. see. All right, I'm back. I guess any questions or anything about that? I know that was a good bit of information. Cool. All right. Well, again, feel free to throw this stuff out in the chat whenever, and I can just jump a little bit into some of our workflow and some of our process. So typically we do, as I mentioned, a bunch of different types of projects, whether they are VR or AR or games or education and training. They kind of really follow the same three major steps. And what those steps are is collecting resources, getting our reference material, creating the 3D assets, code, whatever, and then we're calling it Unity integration, really integration in whatever workflow that we would use in Unity or in Snap Lens Studio. So I can quickly run through some of this. Oh, Andrew, so as far as specific VR packages in Unity, those are changing quite a lot. It used to be kind of every VR thing had its own specific plugin or toolkit that needed to be integrated. Now they've moved to this package manager. And they've got their XR interaction toolkit. Potentially pull up some Unity projects, show off a little bit of what we've done recently. But the long story is Unity is kind of moving to this new integrated XR interaction where it really is going to become to the point where you more or less just check a button and say, okay, I want this project to be a VR project. The camera is then driven by whatever your heads-up display is. It kind of solves all the things behind the scenes for you, whether it's targeting HoloLens or targeting a phone or a VR headset. And so ultimately that puts the pressure back on you to figure out, okay, how to make my app perform in whatever platform I'm targeting. So in terms of Unity specifically, I would recommend their XR interaction toolkit if you're just starting out. It has some great examples. It has some great pieces there. We also have sort of developed our own toolkit that is, we call it Spatial Interaction Kit, or SIK, SIK for short. Here, I can, but yeah, let's see. So yeah, let's see. In terms of recommended tutorials on Unity, yes, let me quickly work on some of those as we, I'll definitely post those into the chat or forward them along. Phil, is there any kind of reference that we'd want to, any way to pass stuff along afterwards, like an event link or something like that?
Yes, we will post it. We will post it when we post it on YouTube. So we'll have some language and include any links. All right. So send them to me and we'll get them a bit. We'll make them available. Yes.
Okay, that's great. I mean, because I'd say things are changing all the time. Unity Hub introduced a lot of good ones, and there's obviously the kind of basic Unity get to going to get started in Unity VR specifically. But again, as I mentioned, it's kind of changing all the time, and they're just moving to this newer way of doing things that once it gets fully ironed out, I think is going to be a much more flexible way to build content for VR and AR. Cool. All right, let me just jump back in to quickly. slides here. So yeah, this is the first step in the process is we just get as much resource material as we can. All the reference, like this is going to quickly run through a project that we built for Union Mills, where we were recreating a classic water-powered mill in augmented reality. And so the first step was to find as much reference material as we could, and really because we had to build it. The first step was to the next step after collecting references to actually build this thing. And I see Andrea asked about our YouTube. Yes, we are just BaltiVirtual. So check it out. I think I can post this in the chat as well. And actually I can show a video from there. So yeah, here's a quick video that explains this project a bit. So again, this was augmented reality using an app. You scan a coaster, this mill pops to life, kind of floating there. And this is the cool one. We wanted to show the inner workings of this water-powered mill. And so you could tap on it and it would hide all of the exterior of the building and show you kind of the flow of grain through it, show you like really what was going on inside. And I think kind of touching on the previous example of this is really the true power of this stuff, is when you can interact with a digital object like it's a physical one. And so the ability to have a 3D model of a mill that you can say, okay, now cut away, show me everything inside it, or give me a 3D model of the human heart and use that to teach kids about biology and how things work, or give me a 3D model of whatever, a volcano, what's going on inside. The ability to not just see those things digitally on a flat screen, but to interact with them like they are physical objects is extremely powerful. So anyway, kind of moving into, so this is the end result of this project, right? This 3D digital model where you could tap and do this stuff. Really what we did was we collected the resources, kind of built up our library of how are we going to build this. Then we went in, it was time to model and animate. And so our art team uses a software package called 3D Studio Max. There's also Blender, which is a great one that's free. There are a bunch of different ones out there, whether it's Maya or Cinema 4D or any number of 3D modeling packages. But in our case, we're using 3D Studio Max. And so we build all of the geometry that goes into that experience. And then we create textures for it so it looks realistic, and export it and get it ready to come into a game engine. I guess one quick note here, as I mentioned, these programs like 3D Studio Max and Maya and Blender and so forth, I think there's going to be a shift in the not too distant future into using programs that are native to VR and AR for these types of content creation. And because right now the existing software packages, you're modeling in a 2D window, right? You're using a screen to create 3D content. And there's always kind of that disconnect where you're looking from the side view and the left view and the top view and the front view, and kind of trying to interpolate between those things in your brain to imagine the full 3D shape of the object. You're turning the camera, or you're doing this, where in Oculus Quest or in AR, like the HoloLens demo I showed, the ability to actually create in front of you and walk around something, chip away or paint this side of it, treat it almost like you're sculpting or painting a miniature or something like that. It's just a lot more intuitive. It's a lot more powerful. We had some students that were interning with us last summer, and actually we've done it for a few years. We unfortunately couldn't this year, but we taught them they were art students, and taught them how to use the tools that we use, 3D Studio Max, and so forth. And they got it. It's a little slow to learn. You kind of have to figure out, like, all right, this is the shortcut here, and this is how I can do these types of things. But it took them about 2 weeks before they could really know their way around and build very simple things. We also gave them the VR versions of some of those things, like VR programs like Oculus Medium, or there's a good one called Gravity Sketch. There's also a very popular one called Tilt Brush, which is by Google. And again, these are, you can see here, in 3D Studio, you're going through and kind of rotating your view, and you're dragging vertices around in these windows. In Tilt Brush, you're moving a controller. You're coming up over here, you're drawing a line in 3D like this. You're drawing shapes in 3 dimensions. And it was just amazing to see what it took someone a few days or even weeks to understand and to be able to build in traditional 2D software packages. Once we got to doing it natively in VR, they could just kind of create. And so I think there's a huge opportunity there in VR content creation tools that are based in VR or in AR. And no one's really mastered that yet. No one really has it completely figured out. I know Unity and Unreal both have versions of their editors that can run from within VR. And I know Adobe's building some things there, but really no one's perfected this. So I think that's going to be a really cool opportunity. And so finally, after we build the 3D assets, we import them into the Unity game engine or Lens Studio or whatever software package we're using at that time. And this is really where we kind of go from a collection of models and animations to a scene and an experience. And so that's where we build the interactivity. Like, we script up, okay, when you tap on this object, this disappears. Or we script things like the OVO's game, where this is how the logic of the game works. We're pulling back, releasing. That's how the shot can either be successful or unsuccessful, things like that. So this is kind of where the magic happens in many ways, is this integration step where it all kind of comes together. And this is where a lot of our team works. So from a development perspective, we've got a team that's really fairly evenly split between programmers and artists, and they work together in those first 2 steps that I showed in terms of modeling material, kind of building base interactivity, combining it all into the final experience. And then it gets handed off to our quality assurance or testing team, where they're running through every experience over and over again, trying to see, what situations we haven't accounted for, where things might be broken, where things could be better, and sort of finding all the rough edges that we've left in the product. Cool. I guess I'll pause for a moment there and see what other questions there are about development or AR, VR, kind of opportunities for building. I think, again, this stuff is really relatively new. So a lot of our applications have been on the more business to business side, trying to find ways to engage and entertain people. But it's not quite to the place where video games are, where there's a large market. If you build, a indie game, you have a chance of being able to find a market of fans that can support you in developing that. Whereas in VR, those numbers aren't quite there yet.
Will.
Yeah.
I've heard and seen some examples of people using VR for training. Have you done any of that?
Yeah, absolutely. VR has been used in a number of ways for training, whether it's, we got our start in 2006 with VR, building a training tool for the NFL. We've done the project that I showed earlier, the NetC, was kind of a training for soldiers to assemble this piece of equipment. And it's a fantastic way to teach people. We've worked on, partnered with some training for different professions, whether they're utilities or even things like soft skills. There was a great study done that was using VR to train managers, and it made them much more effective at being able to deal with employees that were upset with them or things like that. So yeah, it's a very, very powerful tool for training.
It is.
Cool. I also have just a few slides of things that I think are interesting.
Okay, why don't you show those, then we'll
VR
wrap things up, okay?
Yeah, absolutely. Cool. So here's my bonus slides. Cool stuff. This is something, it's sort of similar to our Minerva project that NVIDIA has released. It's called Project Holodeck, and I think they've changed the name to something more like their XR toolkit or something. But it's really amazing because it allows engineers to walk through physical feeling models of, in this instance, a car, even if they're spread around the world. So a lot to be done there. Really, really powerful, especially this idea of remote collaboration in today's world with all the physical affordances. Anything better than kind of the video windows that we're accustomed to. Interactive training. So this is the one I was trying to pull up. This is kind of one of my favorite examples of training. This is made by KFC. It was somewhat of a joke, but it showed people how to make chicken. Oops, I got an ad. But yeah, give it a second. And it was pretty funny because let's see. Sorry, yeah, here we go. The chicken. So you're essentially taking the raw pieces of chicken, picking them up, inspecting them, putting them in the fryer. It actually walks you through step by step every piece or every step of the process that someone would learn when they go work at KFC. I had a summer job at a fast food restaurant, and when I started as a kid, one of the first things they did was kind of sit you down in the back room and watch this training video. And I guess I would have been so psyched. And here we go. The Colonel zaps the rubber ducky so it doesn't become part of the meal. But yeah, I would have been so psyched to have a VR training tool instead of just watching a typical 2D video. So VR training, super powerful. AR is awesome for showing what products look like in your space. This is an example of an app that IKEA built. A lot of different brands are using the same type of technology, kind of try before you buy. Amazon, Home Depot, it's becoming much more prevalent for people to use these kind of light AR experiences to kind of try before you buy. And actually along those same lines, I know we sort of touched on the hyperlink project, Phil, when we were talking earlier. This might be sort of a fun demo. Let's try the unicorn, because I think you could do the turtle later. So have a unicorn hang out in the room with you. So if anyone has their smartphone handy, feel free to scan that code and then find an open spot on your floor. It'll prompt you to sort of move left and right with your phone, and then you get a free unicorn as your gift for coming out today. Cool. I think I'll just probably leave it there. Again, let me see if I can add.
Well, I think that's a great way to end the program, and I'm sure everybody in the Zoom room and also on Facebook learned quite a bit about augmented reality, and it's certainly the wave of the future, and we're all going to be more involved with it. So thank you very much for presenting to us today, and good luck with your future projects, and have a great evening.
Awesome, Bill. Thanks so much for having me. And Andrew and everybody else, appreciate the great questions. If you want to get a hold of us, BaltiVirtual.com and on all the socials at BaltiVirtual. We love answering these questions and engaging with people that are learning. So thanks again for your time. Take care.
Take care.